the law of sines and the law of cosines. Beyond right triangles, we can actually figure out with any triangle, obtuse, acute, equilateral, how long the sides are and what the angles are with the law of sines and the law of cosines. The law of sines works if we know two angles in one side or two sides in one angle. And it's simply this. The law of sines simply says that get the length of side A right here over side A is equivalent of length of side B over sine of B. Now, what I want to recall here is if we're talking about a side here, here's side B, the angle is always the opposite of that side. Here's side C, here's angle C, here's side C right here. Angle A, side A. And we just need to know what the sine is, such as by going through our calculator. Let's look one on here. I know the angle of 30 degrees and 45 degrees. And since it's 180 degrees in the triangle, the remaining one's 105. That's what it in. So we know two angles on one side, 30 degrees and 45 degrees. And we know side 2, which is opposite of 30 degrees here. Right there. 30 degrees opposite of 2. So using the law of sines, here's my 2. Here's my sine of 30 degrees. And I want to figure out what length B is right here. Well, that is the opposite of 45 degrees. So I've set it up where 2 over sine of 30 degrees equals A, my hypotenuse, over 105 degrees, and B, right here, sine of 45 degrees. Because we know the 2 in the sine, 30 degrees for the side, and we already figured out the angle for 105 right here. The opposite is A. And as I said a moment ago, the opposite of B is 45 degrees. So let's do what side A is. I got 2 here, and the sine of 30 degrees, I use a calculator, I just put in sine of 30 is 0.5. And then A is on the other side, and these are just proportions. That's all we're doing. And then if I put in sine 105 degrees, the result is 0.9063. Now I basically am just going to multiply these proportions, multiply this time over here, and then divide by 0.5. So it's 0.9659 times 2 divided by 0.5 will equal my A, which is my side A. And that ends up being 3.87. So side A is 3.87. And we can do the same thing with side B. Where I got 2 sine 30 degrees equals B, and the opposite of B is 45 degrees. Sine of 45 degrees, this should be B right here. And here. Sorry about that. Sine of 45 degrees, 0.7071. So again, I was going to do proportion, multiply this right here. 0.7071 times 2 divided by 0.5 will equal my B. And that ends up being 2.73. So this is 2.73. And remember, to be a triangle, any two sides must be greater than a third. And I can add this B and this 2 up. 2.73 plus 2 is 4.73. That's greater than 3.87. 3.87 plus 2 is 5.87. It's greater than 2.73. And then 3.87 plus 2.73 is already greater than 2. So this makes sense. Do another one here. I know I have a side of 6, and the opposite of that is 71 degrees. So I know it's going to be sine 6 right here. I'm sorry, 6, the side of 6, over the sine of 71 degrees. And I want to figure out my AB, this length right here, And that is going to be the opposite of that is 48 degrees. And the sine of 48 degrees is 0.7431. And the sine of 71 degrees is 0.9455. Multiply this over here. 0.7431 times 6 divided by 0.9455 will equal that length. And that is 4.72. So AB here is 4.72. And now we're going to do AC. And AC, it doesn't give us the angle, but we can use common sense because there's 180 degrees of triangle here. Now subtract 48 and 71, which leaves 61 degrees here. So it's going to be still sine 6. I'm sorry, the side 6 over sine 71 degrees, same as before, which is 6 over 0.9455 equals my AC over sine of 61 degrees, the remaining degree we had to figure out. Sine of 61 is 0.8746. Multiply this up here times 6. And 0.8746 times 6 divided by 0.9455 equals the AC length. And that ends up being 5.55. So now we got all three sides here. And all three angles. Do another one here. Now I've got two sides here, and I've got an angle of 40 degrees. So we can figure this out, the law of sines, of not only what the other angle is, but the other side as well. So I know 40 degrees is opposite of the side of 30 meters. So I set that up. 30 meters over sine of 40 degrees equals 40 meters, this one right here, and I don't know what this angle is, but it'll be sine of this right here. So when I rearrange this, I get 40 over sine of unknown equals 30 over sine of 40 degrees, which is 0.6428. Multiply this over here, divide this, the 30 over here, and move the sine up over here, which is what I've done here. 0.6428 times 40 equals, over 30 equals sine of these degrees. I get 0.8571 for the sine, but I need to do the angle, so I do the negative, do the inverse sine. So sine to the 0.8571 to the negative 1 is, use your calculator this, 58.99. So this side, I'm sorry, this angle is 58.99 degrees. And I put meters there. Should be degrees. Do one more. We know two sides and an angle. And the opposite of this angle of 20 degrees is 12. So it's going to be 12 over sine of 20. And I want to know this angle A. Opposite of that is a length of 19. So I'm going to put 19 on this side. And again, this is proportion, sine A. Sine of 20 degrees is 0.3420. Don't know the sine on the other side, that's what we're looking for. I know the lengths are 19 and 12. I'm going to rearrange this, multiply 3.3420 times 19, divide it by 12, and then multiply this times sine up here. So I end up getting 0.3420 times 19 over 12. This is just rearranging the proportion. And that ends up being 0.5415 is the sine. We do the sine of the negative 1, the inverse sine. And that angle is 32.79 degrees for angle A. So this is right here, 32.79 degrees. Like that. Now, the law of cosines is really just a derivative of the Pythagorean theorem. Is ultimately what we're doing is we are gonna with the law of cosines, we're going to divide the triangle. I'm not going to go through the details of how we arrive at this, but remember, triangle area is base times height. And that base is always vertical, and there's a right angle right there, and a right angle right there. And that's really what we're doing with this. Let me erase this, because really, if you look at the law of cosines, it's c squared equals a squared plus b squared minus 2ab cosine c. But the gut of this is the Pythagorean theorem. And there it is right there. This just is the derivative of it, where we're dividing the triangle up into two right triangles, and we can figure it out. Let me erase this right here so I don't get too confused. And when we're looking at this, again, this is basically a plug and chug. We plug in the numbers, we chug them out. And the C we're looking for isn't always hypotenuse because these aren't right triangles. But if we know, we can do this if we know two sides and angle between them, or more commonly, when we know all three sides, then we can figure out what the angles are. And let's suppose we're looking for angle C right here. Well, that's opposite of this side there, 8. So that's going to be my C. And then I'll put my A and B squared right here. Opposite of my A is 9. Opposite of my angle B is 5. So 8 squared, my C squared, equals 9 squared plus 5 squared minus 2 times AB, 2 times 9 times 5 times cosine C. And this is all multiplied together here, so we got to be careful with this. So 8 squared is 64. 9 squared is 81, plus 5 squared is 125. And I really took a long way, because first I subtracted 25 from 64, got 39 here, and then I subtracted 81 from 39. I should have just said 81 plus 25, which is 116 minus 64. Is 116? Yeah. No, 106. 81 plus 25. Let's see. Yeah, 6. 106. Then subtracted that from 64, and I get minus 42. I did two substitutions as one. So minus 42 is going to equal, let me erase so we're not too confused here. This part right here. 2 times 9 times 5. 2 times 9 is 18 times 2 times 9 is 18 times 5 is 90. 18 times 5 is 90. Cosine C. So this equals negative 42 equals negative 90 times cosine C. I'm going to divide both sides by 90 here. So what I end up getting is cosine C equals negative 42 over negative 90. Two negatives here make it positive. It's cosine 42 over 90. And when I divide 42 over 90 and then do the inverse cosine, like we did before, I get 62.2 degrees. So this is 62.2 degrees right here. And truthfully, as I told the classes before, once I know one of, I got almost three sides. Once I know one of these sides, much easier to do the law of sines after this, because now I know an angle and a side. I can just use the law of sines. But this is really useful if you only know all three sides. One more here. Law of cosines. C squared equals A squared plus B squared minus AB cosine C. And we want to look for, it looks like we know two sides and an angle. And again, we could use the law of sines here. But let's use the law of cosines, and we'll get the same answer. X for A, Y for B from the A squared Z squared minus 2AB cosine C, and then Z for C. So we know our Z is 131 degrees. So let's take a look at this. The angle is 131 degrees cosine. We now know our length of Z from here to here. So Z squared equals A squared, which is 9.4 squared, plus b squared, 6.5 squared right there, minus 2 times 9.4 times 6.5 times cosine of that c, which is 131 degrees. 9.4 squared is 88.36. 6.5 squared is 42.25. Minus 122.2, which is 2 times 9.4 times 6.5. And the cosine 131 degrees is negative 0.656. So when I add all this together, 88.36 plus 42.25, I minus 122 times negative 0.656, I end up getting a z squared, 130, I'm sorry, it should be 130. Yeah, 130.61 or 88.36 was 42.25, and then negative 122.2 times negative 0.656 is plus 80.17. Those two ended up together ends up being 210.78. That's z squared. The square root of that, 210.87, is 14.5. So my length here is 14.5. And that is how we developed the law of cosines.